So this is Dr. Manas Mahapatra, School of Mechanical Sciences, IIT Bhubaneswar. Today we are going to discuss regarding the deep hole drilling process to measure the through thickness residual stresses. Now this is a single station deep hole drilling setup which we have developed over the years at IIT Bhubaneswar. Now in this technology what happens that in thick section weldments and in thick workpieces, if we need to measure the stress through the thickness, then we can measure it very conveniently and very accurately. Now as you can see here, this is a job of 40 mm thickness welded plate. Now we are stationed that and we will be measuring the residual stress through the thickness through this technique. What happens that in this technique, a reference hole is first of all drilled and rimmed up to the required dimension. Then what happens that that particular reference hole is trepanned. So when we trepan it, then what will happen that that will be stress relieving, and that relief of stress will be measuring, and in terms of dimensional change of the hole through the thickness, and will be calculating the residual stress. Now as you can see here, we are advocating a single station deep hole drilling process, because we have observed that if we go on changing the location of the job, then our accuracy gets disturbed. Even a micron level displacement may lead to much inaccuracies. Now to know whether our residual stress values are okay or not, we also do a series of validation tests. For example, as you can see here, this is a bar of around 25 mm thickness, and in which we have already induced a known value of residual stress by partially plastically bending it, then subjecting it to the deep hole drilling process as you can see here. So theoretically we know how much residual stress is there, and we also know through these strain gauges here what is the residual stress to the thickness, and also by deep hole drilling process, as you can see here, we will be able to calibrate it if at all there is any inaccuracies, or we will be able to know whether the dimension of the core hole and the trepanning whatever you are using, those are correct or not. Accordingly, for various thicknesses, this validation procedure has to be developed. For example, you can say that for large thick weldments, we have validation technique, but certain time the stress field is narrow. For that reason, what happened, we have developed a range of what we call the trepanning tools, gauges, and all the validation techniques. You can see here, these are the trepanning tools for various thicknesses or various width of the stress field. Now we have also here developed the various gauges. We have specified them to gauge manufacturing company, and they made it according to our specification. Thereby we are able to measure the stress through the thickness very correctly. Now here you can see a 40 mm thickness plate, and you can see here a superalloy pipe. You can see a pipe joint, and through the thickness at the weld zone we are able to measure the residual stress. Now here you can see the bushing etc. we have ourselves developed, so that the accuracy of the particular measurement is very good. Now the measured values, then we take into computer. We have our own Excel based program through which as we measure it, then we also get the residual stress value on our computer terminal. Now through this technique at our laboratory, we can measure residual stress up to 100 mm thickness very conveniently. With some tooling we can go up to 200 mm thickness, and it can be utilized for casting, welding, forging applications, even machining applications. It can be applicable for subsurface stress from 0.5 mm depth onward. Now as you can see here, these are some of the tube joints, these are some plate joints, and here you can see some of our board joints, long board joints. Through the thickness we have been able to measure the residual stress. Now while measuring it, we also take into account that whether our measuring process is accurate or not. Now in our field, that is the most important thing, that whether the value of the residual stress we are getting, that is correct or not. Validation procedure we develop so that for a set of jobs we validate that what is the measured values, whether they are accurate or not. Now this type of setup are not available internationally. According to our information, some European countries have developed them in their laboratory and they take turnkey projects. Any industry who wants to measure through the thickness residual stress can take this technological help from us, because we have developed all the aspect of this technology here in India itself. To our knowledge, no commercial setup is available in India. Whatever available abroad, that is also not widely available. You have to contact the lab and they do it for you on project basis. It will be of great help to industries and researchers where we need to measure the residual stress through the thickness. Thank you.